Life is really to tell.
Hello guys, I'm coming back with my vlog. This is your content creator, Carol. Zoom Zoom. Our topic for today is again a continuation of reduction and oxidation, but this time it's gonna be reduction and oxidation in acidic solution. Okay, things like that. So we don't go to many examples because if you solve or if you know how to do the redox in acidic solution, the just one or two examples, then the rest will follow. Okay. Wait for a while, guys. So example for okay, reduction, oxidation in solution. Okay. So we need to give you the steps on how to do it. Number one, we need to determine the oxidation states of each element or compound in a chemical reaction, the reactant and the product. That's number one. So, okay, determine the oxidation numbers or oxidation states. Then after assigning the oxidation states, then we can really distinguish which undergo oxidation and which go reduction. So it's gonna be like distinguishing, okay, after determining no, sorry guys. Okay, knowing the oxidation and reduction. So it's gonna be half reactions. Okay. And then, of course, you need to balance atoms and the charges. Balance the atoms and the charges. And then, after that, you can add electrons for both oxidation or reactions, right? Okay, reactions. This is acidic. So if there's a deficient of oxygen atoms, you need to add H2O plus H2O and then compensate that also with adding H plus. Every time you add water, you add also H plus. And then number 5, okay, adding both half reaction. Adding both half reaction in number 3, okay. In number 3, okay, and ensure electrons are cancelled. Ensure electrons are cancelled because the adding of electrons will not participate in the net redox equation. Okay, then net redox equation is the step number 6. Okay, you need to follow these guidelines when you do the reduction and oxidation in acidic solution. Again, step number 1, determine the oxidation numbers and states. Then initially at this, so you need to visually inspect if the reactants and the products are already Okay? Okay, guys. So you can see now the steps of reduction oxidation. Okay? So that's very clear. We have at least 6 steps on how to do the reduction and oxidation in acidic solution. Right? Okay. Any questions so far? I'm on at the back. Okay. Because I need to drink water. Okay. So, nauuhaw ang inyong lulo ngayon. Char. So, ganun talaga ang nangyayari. Okay, guys? So just concentrate on the 6 steps as you can see in the whiteboard. And you're gonna apply that again and again and again in different sample examples for this redox. You get the point? Things like that. Okay, guys. So again, water first. Because I cannot breathe. Okay, I cannot breathe properly. Right? Okay. Reduction, oxidation steps in acidic solution. First, determine the oxidation numbers and states. So in this time, at this point in time, you can visually inspect that the number of atoms are balanced already. If not, just proceed because somewhere along the way, you can balance still the atoms in the later part. Okay, number 2, knowing the oxidation and reduction have reaction because you assign already the oxidation numbers and states. Okay, so that's really the method in doing this. Okay, number 3, atoms and charges and add electrons for oxidation and reduction reactions. Okay, this is gonna be the half reaction. It means here in number 3, half reactions. Number 4, add water for the deficient and oxygen during the balancing of your atoms, and you may add also hydrogen on the other side to balance really the hydrogen atoms and the oxygen atoms. Okay, number 5, adding both half reactions in item number 3, then ensure electrons are cancelled. Okay. Number 6, net redox equation will be there. Okay, let's give an example. Did you write now this in your blank sheet of paper, class? Okay. But this kind of general chemistry lecture is more now on college level, introductory. Because you know, the chemistry in high school will not be going into this far. Okay? In understanding about reduction and oxidation, there will be only introducing the basic concepts of what is an oxidizing agent, reducing agent, substance reduced, substance oxidized, like that, the process of oxidation, the process of reduction, but it will never go into this a little bit of details 1 to 6. Okay, get the point. So examples. Okay. So your takeaway here is the adding of H and H2O because the other steps are mainly you're applying that most of the times in your chemical reaction, especially the balancing of atoms. Get the point? And you can apply this also in ionic equations, but there you're focusing on the ions. Ions balancing the negative charge and the positive charge. Here, the electrons being transferred if loses electrons or gaining electrons. That's only the difference. Okay? Get the point. So, ion equations, charges, the positive and negative charges, an ion and a ion. But here in the redox equation, you are focusing on the transfer of electrons. Okay, but don't be confused also with the sharing of electrons. Okay, in the outermost shell, because that's another topic also, the chemical bonding, the covalent chemical bonding. Okay, that you need to remember the valence electrons in the outermost shell before you can make the structural formula, the chemical formula, things like this. Okay, you get the point. Now here, example. Okay, bromate, okay, plus zinc is equal to bromide 1 plus zinc 2 positive. Okay? Things like that. Okay, you may wondering why, guys, know that it's gonna be sometimes zinc 2 positive, zinc positive 2, right? You may wonder that why sometimes, right? Because when we mean of 2 positive, this is oxidation state. Oxidation number. But we mean of positive 2, that is charge. Okay? Things like that. So if the sign will go first in writing, say positive 2, positive 3, positive 1. These are charges, negative 1, negative 2. But if we mean 2 plus 2 negative, that is oxidation number. Oxidation state. But actually, it will just be the same if you, it doesn't matter as long as you really understand whether you put 2 plus or plus 2. If you really understand the whole process, it doesn't matter, but I'm talking only with the uh, preciseness on how to say or on how to write, because it doesn't matter somewhere along the way of your entire redox reactions and equations. Okay? So step 1, assigning oxidation states and oxidation number. Okay. So you need to take into consideration that the pairing, for example, if there's bromine here in the reactant, you go also to the bromine on the other product. If there's a zinc here, you need to pair that with also zinc in another product, could it be an element or in a compound, as long this element is present. Things like that. You don't have to pair different. Okay? You get the point? Different elements in the particular compound. Okay? You get the point? Things like that. So C, understand C. BrO3 pair with Br. Zinc pair with zinc positive 2. Okay, now, let's determine loses electrons and gain electrons. Okay, the first thing to do is to determine the oxidation state of bromine and oxygen. So let's do the trial and error method first to make it direct. So oxygen, negative 2. Negative 2 times 3, negative 6. So negative 6, you have to add to something, okay, that will be equal to the negative 1 net charge of bromine. So you need to assign value. 5 minus 6, 6 minus 6, 7 minus 6. So what will be number in order we can have negative 1? So it will be, okay, 5. This is trial and error method, okay? So 5 minus 6, negative 1, negative 1. Okay, things like that. So, since this negative 6 is for oxygen entirely, so the 5 is for bromine. So put positive 5 for bromine. Like that. Now, if you use algebraic expression of getting the oxidation states and oxidation number, so this would be much better with formula to follow. Okay, let's say bromine plus subscript 3 times oxygen is equals to the net charge negative 1. So bromine, okay, plus 3 times the charge of oxygen negative 2 is equals to negative 1. So Br, so 3 times negative 2, negative 6 is equals to negative 1. Br is equals to negative 1 plus 6 transposed to the right. So Br is equals to 5. So our Br is 5. So it's up to you what method you will be able to use. But for me, I like this algebraic expression or with formula in getting the oxidation state and oxidation number because it looks like perfect all the time. Okay, compared to trial and error method. Okay? Things like that. But if you are really expert and master in assigning values in your trial and error method, then you can do that also. It's up to you if you are convenient with that. Okay? Things like that. Okay. Bromine starts from positive 5 and passes to negative 1. So what does it mean? it reduces the oxidation state. So once it reduces the oxidation state, okay, it's obvious that it gains electrons. See? The positive 5 becoming big, the negative 1 on the product. So meaning gain of electrons. So this is reduction. So when we say gain of electrons and loss of electrons, look at, okay, the oxidation number and oxidation states in the reactant, whether it is big or less compared to the product, so that you can say which among them loses electrons and gains electrons. Because the oxidation state and oxidation number increases and decreases are the opposite of this electron thing. It's more easy. That's why, based on the experience or based in teaching in chemistry or in the books discussion, they would normally refer the increase and the reduction of the oxidation numbers and oxidation state to identify whether your reaction is a reduction or oxidation, rather than determining the losses of electrons and gain of electrons. But it doesn't mean that you don't have to understand that. You retain the concept, okay, but only for this purpose of having the redox balancing in acidic solution or basic solution, or simply only the redox net equation or half reaction or whatever. You get the point? Things like that. Okay, since gained electrons, obviously, gained electrons is the reduction. Okay, so because there is a confusion. Gain electrons, then reduction from English language. Once it gains electrons, then why it is reduced? Right? So that's also not good to parallel in our memorization. That's why they only use the oxidation state, because see, the oxidation number, positive 5 goes to negative 1, so it decreased or reduced. So it also compatible to say reduction. In our memorization, it's very easy to detect the oxidation state determination, oxidation number changes, not the losses and gaining of electrons, because it's the opposite thing. But you don't have to remember, because most of the examination will ask for the electrons in the future. So blank is the process that will gain electrons. Okay, A blah blah blah, B blah blah blah, C blah blah blah, D blah blah blah. It's not talking also the oxidation state. Okay, that's why I told you that you have to retain the concept. But for the purpose of this particular topic, in this context, we need to go over with the determination state and oxidation number. Right? Too much talking, right? So this is gonna be reduction. Okay. So let's make this precise first, and emphasis will be done first. Okay. Reduction, meaning bromine is reduced. Okay. Like that. Then, the reduced concept and the oxidizing agent, like that, is the reverse. So, reduced oxidizing agent, oxidized reducing agent. Since bromine is reduced, meaning to say this is oxidizing agent. So during your memorization also, it's a reverse. You don't have to take the clue. Because if you take the clue, oxidize, you can say oxidizing agent, but it's the reverse. You get the point? So that during your memorization, you will never be mixed up. That's the purpose. So reduce versus oxidizing agent. Okay, so bromine is reduced at the same time with oxidizing agent in the process of reduction. Things like that. You get the point? From positive to negative 1 kasi, right? Okay. So, it deviates from our general rule and general concept that most of the non-metals and gases, okay, things like that, are oxidizing agents. It's okay, oxidizing agent pala siya. Sorry! Most metals are reducing agents. Okay? Most non-metals are oxidizing agents in our, complete package memorization. Okay, not on the mechanics how to operate this redox. Okay? Things like that. You got the point? Okay. Since reduction is that, then take look with your atoms. So there's an oxygen involved. It's so strange. Then you don't have oxygen on the product. Strange, okay? So initially it looks strange, but you go to the process in determining the half reaction so that we can introduce oxygen atoms there. Okay, that's step one, no? Okay, oxidation will be the zinc because from 0 to positive 2 or 2 plus. Alright, so increases oxidation number. So we need to say loss of electrons, then oxidation. Okay, we label perfectly so that during our half reaction, half redox, it's very clear what to write in the next step. Okay, now we go to half reaction. This is called half redox. Okay, reactions. So we oxidation. Oxidation. So let's not be lazy to write first for the purpose of discussion. The moment you face an examination or test in the future, you don't have to write anything, right? Things like that. As long as you understand already the whole process, then class. Okay, you can really answer comprehensively. Okay, things like this oxidation. So it's here. Okay, so zinc. Guys, don't copy the 0 during the half reaction. Okay? Things like that. You can copy only positive 1 above, but never copy 0. Listen this one. Okay? So zinc is equal to zinc 2 plus. Right? Now, how many electrons loses in this or oxidation state changed? It's 2. So in our half reaction, we will focus to electrons because we are dealing with adding of electrons. So it loses 2 electrons from 0 to 2. Okay, now you will put adding of electrons in the right. Plus 2 electrons. Why? Because the reverse reduction is gaining of electrons. Normally, you will add that to the left, okay, in the reactant. Okay, see? So, zinc is equal to zinc 2 plus 2 electron. Okay, here anything? Balance? Okay, go to atom. 1 atom of zinc, 1 atom of zinc balance. Now, charge. Okay, the charge. Okay, 2. Okay, things like that. Times 1, 2. Plus 2 electrons. So 2 plus 2 electron. Because 2 electron is negative, so it becomes 0. Okay, here. So, oxidation state of all solid-like elements or in a free state, meaning single element only, it's not a compound 0. Therefore, 0 is equals to 0. Their charges are balanced. Because you will never proceed if the charges also are not balanced. Okay? I'm just telling why it is balanced because of this electrons you added. Okay, 2 electrons plus 2, the oxidation state, it will become 0. Ganon. Now we go to the reduction. Okay. Now, if it happens, there's oxygen here in your oxidation, you will add water and H+, but nothing, right? You don't have to be bothered for that. Okay, we go to reduction. Okay. Because the takeaway is, every time you add water, you add H+ on the other side, and the rest will follow. Because you know already how to balance charges and atoms. You know also how to distinguish oxidation and reduction. So even though you will memorize only one thing class, the whole process will be in complete package. You don't have to worry about steps 1 to 6 if you really understand what it means. You get the point. So reduction. Okay, here, copy BrO3 negative. You need to do the whole thing, during your oxidation reduction. Okay, then the partner will be Br. So partner Br negative 1. Now take note. You have to add electrons in the right. Oh, in here, in the left. Sorry, because I'm facing of you. Right? I'm facing of you. Just you face the whiteboard. Then it's gonna be left. Left here, right here. Okay? So just say reactant to make it short. You add electrons in the reactant, even in which you don't know. Okay. The others also, before when I was in high school, okay, because I also studied this in high school, even though, it's not really that going to this far. Meaning I studied a little bit advanced. Things like that. Okay, so if you mean adding of electrons here, okay, some or me also, in the past I'm a victim of this also, you need to add electrons based on this one, right? This is really reduction. So how many, okay, gain electrons from bromine to bromide negative? You will see 4, right? 4 electrons directly in adding here. Take note, it's not all the time that it will match. If you take a look with this kind of those kind of electrons, because sometimes it will change. Sometimes it will change. So do not follow the 4 electrons adding here. But the technique, you have to add electrons in which you don't know yet. That's the point. Things like that. How can you do that? I am a fan of algebraic expression as usual. I will use always algebraic equation, letting x, letting y the unknowns. So let x as your number of electrons in your reduction. So x. This I will explain to you. So bromide plus x electrons will yield bromide negative 1. Now, this is the thing because bromide have oxygen atoms. So this is not the thing I will be used. So we need to add water, okay, to the right because it has deficient oxygen. See, nothing. So to compensate that or to equal the insufficiency or the deficiency of atoms from the reactant, we need to add 3 moles of water to compensate the 3 atoms of oxygen. So we have now 3. Then you need to add on the other side H plus. So H plus or hydrogen ion. Okay? H plus is specific rather than hydrogen ion because if we mean ion, that could either be negative and positive in chemistry grammar. So I will never say H ion, I will say H plus because it's understood that it's cut ion, not the anion. So I will add 2 times 3 is equal to 6H. Okay, so plus 6H positive. You need to carry the positive upside. Why? Because you split the elements in the compound. Do not forget because once you add 6H only, you are losing the concept of balancing the charges. You will never balance the charges even though you will commit suicide. If you don't carry the positive of the H, the same also with the oxygen, you have to carry the negative thing. Okay, because once it's splitted, it's automatically being charged, like in the concept of ionization or dissociation of an ionic substance. Okay, get the point? So if it will be charged in aqueous solution, you will always carry the cation and the negative ion or the anion. You get the point? Things like that. Okay, so you will never say H, you will never say oxygen if you split the compound. You get the point? Copy? It will be followed for the rest of our chemical reactions. Okay? Because chemical reactions are never ending. You always see this every time if you look for science books, especially general science education, chemistry will always be there. You get the point? Things like that. Okay. So 6H plus bromate plus X equals to bromide negative 1 plus 3H2. Now, this time, balance now the atoms because we introduce now the oxygen atoms. Okay, hydrogen 6, 3 times 2, right? Oxygen 3, bromine 1. Okay, so balance. Perfectly balanced the number of atoms. So your balance, your remaining to be balanced is the charge. So here, 6 times 1, because plus in chemistry would mean 1 automatically without question or by default. Okay, so here, plus. Okay, negative 1 times 1 is negative 1. So I will put directly negative 1 in math, algebra. But you can see also that positive, negative one, but you add positive and negative, and which is higher is negative, like that, or positive. Depends on the numbers, right? So you get the point. So plus, I will just say like this, parentheses, so that we will not be confused. So negative 1, okay, things like that, times 1. Okay. During the balancing of your charges, you don't have to worry for the subscript. You only have to worry with a coefficient. Coefficient, or the number of moles written beside element and an atom. You apply that with the charge at the top individually. You don't have to take it with the subscript, but if you're trying to determine the atoms, you will be focusing on the subscript times the coefficient, or the number written, very clear, written beside element and compound, so that we can really understand what we are doing. We don't mix up the fun things like that. Okay, any questions so far? Okay. Oh my gosh, for my followers in Facebook. Okay. Thank you so much for watching Teacher Minerva Product of Pusuk Lapu-Lapu City. Thank you so much for watching this educational purpose chemistry. Okay. Things like that. Okay. Charges equal to negative 1. So negative 1 times 1 coefficient. Nothing written beside the element or compound. It's understood to be 1. Okay, that's why negative 1 times 1 plus. Now, water molecule. You need to follow the concept and rule in redox, general rule. Okay, if there's no written charge or net charge at the compound, that would mean the net charge is equal to 0. Okay, so 0 times 3 is equals to 0. So you have to take down the 0, you have to cross the 0 because it doesn't contribute in your balancing of charges. Okay, now here, 6 times 1, 6. Okay, things like, you get the point? 6. Okay? 6. Okay, plus negative 1 times 1, negative 1. Then, you're letting the x of electrons. Because I told you in the concept, you have to add electrons, just like what we did in oxidation. There's an electrons here. But in reduction, we still don't have the electrons, so we let that as an unknown x. So plus x is equal to negative 1. So this is linear, simple linear algebra or algebraic expression. 6 minus 1, negative 5. Plus x is equals to negative 1. X is equals to negative 1. Transpose negative 5 to the right, positive 5. So x is equals to 4. Right? Negative 1. Review for the second time. This is 6 minus 1 is positive 5. Okay? 6 minus 1, yeah, is greater, the positive value is greater than the negative value. So you will say x is equals to negative 1, okay, minus 5. So this will become negative 6. Hala. So is there having a negative 6 electrons? Okay, I may explain this. The sign here negative would mean an indication that this is an electrons. So you will say 6 electrons. Negative at the top. Okay, you will say 6 electrons. Negative at the top. The symbol of electrons is small letter E and negative at the top of it. See? Electron, negative at the top of it. Or others also don't put, as long as we know that's an electron. No question, right? You get the point. But really the books precisely indicate the E of the electrons because electrons are really negative in nature. You get the point? So it is lighter than the neutrons and the protons. That's why it's rotated in the shell, in the energy level of an atom. So an shell electrons, so that is called valence electrons. So it's lighter, that's why negative. Okay, with a mass of 9.11 times 10 to the negative 31 kilogram. This is the mass of one electron rotating in the energy level or in the shell or the last outermost shell of your single atom or single element. Okay? things like that. That's why negative. Imagine negative 31. That's very light. Okay? So things like that. So 6 electrons na. Okay, erase this. Okay, sorry for the very congested space in my word. Okay, now you have now 6H plus bromate plus 6 electrons is equals to bromide plus 3 moles of water. Okay, now add the two half reactions. The oxidation reaction, you see, put the two will be added. Now, before you add the two, ensure that your electrons will be equal from the left and the right. Okay, left in the reduction and in the right two electrons. So you need to multiply for something which is a numerical figure in which the two will be equal. You can cancel that later on because electrons will not participate in our determination of our final redox equation. In the half reactions, it will be there, okay, temporarily, but in the final or the net redox equation, it will be vanished or it will be discarded. You get the point, things like that. So what we will do here, so which is smaller electrons in the oxidation or reaction? Okay, so you need to go to the smaller, which is oxidation. In order to equal that to 6 electrons, we have to multiply this with 3. So times 3. And this is a takeaway. If you multiply 3 of this oxidation, the whole thing of this expression from here to there will be multiplied by 3 also. Because you will be wrong if you will not multiply entirely. Only the electrons you multiply. So this is the whole thing. And so you put parentheses of this whole chemical reaction in your oxidation. So 3 times zinc. 3 moles of zinc. Okay? Get the point? Okay. Is equal to, so this is zinc 2 plus. So 3 times zinc 2 plus. So 3 moles of zinc 2 plus. Okay, plus 2 electrons times 3, 6 electrons. Okay, that is your oxidation. Go to the reduction because you have to add a 2. So put plus here. Okay, reduction. You don't have to do anything because it's already 6 electrons. Okay, equal to the 6 electrons in your oxidation. So you have to rewrite. So 6H plus, copy everything. See, plus bromate, okay, negative, plus 6 electrons is equal to bromide, okay, plus 3 moles of water, like that. Then add a 2. So visual inspection, obviously, you can see 6 electrons common from oxidation and reduction, so cancel that out. Okay. What will be left is your net or final redox equation. So we'll call this as simply as net redox equation. You need to master this, okay, to improve our grades of chemistry. Because most of the times we will be dealing with chemical reactions and everything there. Okay, so net redox. It will be 3 zinc, copy everything. Okay, now the technique here, copy all the reactants in the same position and copy also the all products in the same side. Okay, so 3 zinc plus 6H plus bromate. Okay, is there anything here in the reactant? Visually inspect because the moment you missed one element or one compound, you will be wrong in your redox and the atoms and charges will never be balanced even if you commit suicide. Okay, things like that is equal to 3 zinc 2 plus. See here. So plus bromide negative 1. 3H2O. The technique here, guys, is you don't have to be careless in putting the charges all the time during each step. Because the moment you will miss it, you will be wrong. Because you have to balance that somewhere out of the way. Okay, now, this is your net redox. Balance both atoms and charges. If not balance both, then I'm wrong or we are wrong. Okay. 3 zinc atoms first. Okay. 3. 3. Okay, got the point? So what's, again, review, a very small information. What we mean by atoms? Subscript times the coefficient and subscript times the mole. Okay, but what we mean of mole is only written in the beside the zinc. But here it happens that our moles don't have subscript. That's why we will say 3 atoms. It will just matter if there is subscript in a manner of how to say it. For example, if I will say water, 3 moles of water, things like, you'll never say 3 atoms of water. Because the point is not the same. Okay, so you will say 3 moles of water, so atoms, 6 atoms of hydrogen and 3 atoms of oxygen. So basically, you can never say in a compound directly. You need to break that out individually to say an atom. A compound is chemically bonded with a lot of atoms in it. That's the definition of a compound. Okay? Chemically bonded atoms with each other to produce a compound. And a compound is an example of a molecule. So that's why that's the definition of molecule. Okay? Composed of 2 or more atoms bonded each other or chemically bonded each other. So that's the definition of a molecule. So since water is one molecule, you get the point? Things like that. Okay. There's 3 moles of water. Okay, things like that. So that's why during insane or net redox, we need to be precise. Okay. Hydrogen, 6. Oh, hydrogen also 2 times 3, 6. Okay. Oxygen, 3. Oxygen, 3. Bromine, balance also. You will never say also bromine. Okay, during balancing, you always name the element. Okay? Bromine, chlorine. If you meet oxygen gas, let's say hydrogen gas, during your balancing, you will never say hydrogen gas. Because that's wrong grammar in chemistry. You will say hydrogen. See? This is bromine. But I say, oh, how many atoms of bromine? I will never say bromine. You get the point? So bromine, see? 1. 1. This is only minor details, but we need to be extra careful also. You get the point? So things. Okay, balance the atoms. How charges? Okay, this is zinc here is not charged. So by general rule, it is a 0 oxidation state. So 0 times 3, 0. Okay, plus. So hydrogen is charged to positive 1 because positive it means 1. So 1 times 6, so 6. Plus bromate, so negative 1. See, net charge. So in a compound, guys, this is for clarity, that is net charge times coefficient or net charge times the number of moles. Again, I told you a trillion of times. Coefficient and the number of moles are numbers written beside element and a compound. Sharo, di pa siya kasabot? Okay, so negative 1 times 1. Okay, is equal to. Why do we need to put equal every time? What's the purpose of this? Aside from knowing to balance. Because we need to meet the concept of the law of conservation of mass in chemistry. That everything must be balanced according to its stoichiometric amounts. Could either be in atoms. Okay, could either be in the charges. Like that. So our purpose is just like that. That's why we are doing these things. Okay? To achieve the law of conservation of mass. Part of knowing the law of conservation of mass. LCN, LCE. Okay, law of conservation of energy, law of conservation of matter in chemistry. You have to understand that, and also the law of definite proportion, LDP, and the law of multiple proportion. These are the laws, very popular in chemistry. We need to understand this. Okay, before doing these things actually. Okay, you get the point? Because that's our direction, why we do this. We need to balance the number of atoms from the reactant and product to meet the law of conservation of mass, in which stoichiometric amounts of each reactant and the product will always be equal to achieve the state of dynamic equilibrium. Because once the dynamic equilibrium will not be reached, there will be no activation energy for the chemical reactions to proceed. All chemical reactions all over the world will begin or start to produce a desired product if there is a desired activation energy, the lowest minimum energy to trigger the complete chemical reaction. And part of it, or prior to that, we need to balance everything, the atoms and the charges. And that's the purpose why we are doing this. Okay? We have direction, we have objective. Because if we do something that we don't have objective and purpose, then normally we will be confused in what path we will be taking in the future. For example, I wanted to become an engineer, then your path straight to become an engineer. You don't mix that with other thing in which it could really obstruct and impede your decision or your ambition to become an engineer in the future. It's like that also. The same in our chemistry. You need to go straight where your direction may lead you through. You got a point. And that's very clear. Any questions so far for that? Nothing, right? Okay. So we need to balance the charges here. Okay, class. Okay. So for the charges, here, 0 plus 6, 6, 6 minus 1, it's 5 in the left. 5 charges. Okay, here, it's, so 2 times 3, 6. Okay. Negative 1 times 1, negative 1. 0 ang molic water. 0 times 3, 0. Okay. 6 minus 1, 5. Plus 0 is 5. So, charges are balanced. So, perfect. Both the charges and the atoms are balanced. So, we could say definitely, absolutely, that our net redox in this particular example, in basic redox in acidic solution will be 3 moles of zinc plus 6 moles of hydrogen positive ion plus, okay, bromate is equal to the 3 moles of zinc 2 plus bromide plus 3 moles of water. And I thank you. Any questions so far? You can comment down below in the comment section if I had something missed during my discussion. Though my elucidation is not very clear for you, though I elucidated clearly to you, or am I elaborated perfectly to you, the discussion or not? If there is something, let us say, skeptical in the manner of my discussion, then you can always drop off message the messenger and we can discuss it professionally, and it's in there also that you can be able to suggest what particular topics we will be able to discuss in my next vlogs, especially if you have sons and daughters that are really struggling in chemistry, or if they want really to learn something new, or let us say to make our life so easy. We don't make our life complicated. That's why we are here, vloggers of pure science, health science, okay, and different topics we wish to or we intend to share you guys in a virtual platform of interactive communication and discussion. Once again, this is your instructor, informal professor, engineer Sotero from Musino Junior. Bye-bye, everybody. See you later. Remember that Jesus loves us. Thank you.